Hi, everyone. Thanks for standing by. We will get started in just a few moments. Hi, everyone. My name's Aubrey Johnson, and I'm a product marketing manager for Vault. Thank you so much for joining today's live stream event. So today we're very excited to announce Vault as a fully managed cloud offering on the HashiCorp cloud platform. And joining me today is HashiCorp co-founder and CTO Armon Dadgar and Justin Weissig, senior product marketing manager for Vault. During our session today, we'll jump into our latest product announcement, see a live demo, and then we'll follow that with a Q&A session. Just as a reminder, this webinar is being recorded, and that recording will be made available after post-processing, usually about 2 business days. And lastly, there is an opportunity for you to ask questions. Feel free to submit those into the question box, and we will answer them during our Q&A section. And then with that, let's jump in, and I'll turn it over to Armon.
Thanks so much, Aubrey. And thanks everybody for making the time to join. Very excited for the announcements we have for all of you today. So jumping right in, my guess is for most of you, you're relatively familiar with HashiCorp, given the sort of the nature of this webinar. But for folks who maybe are new to the community, just learning about Vault, just learning about the company, at HashiCorp, our focus is really a broad one. It's really not just narrowly focused on just Vault, but really looking at what are the challenges of modern infrastructure automation, especially in sort of a cloud setting. And so we look at kind of a whole set of different problems. Part of it is how do we think about provisioning and stand up of underlying infrastructure, right? The lifecycle management of, day 1 stand up, day 2, scale up and scale down, day 3 patching. And so there's a set of tools, namely around Terraform and Packer, that look at kind of the provisioning and lifecycle management. Then we look at the security challenges of how do we operate in a modern sort of cloud context where we have highly ephemeral infrastructure, we have poorly defined network boundaries. And so our big focus there is Vault as well as Boundary. We look at the networking pieces as well. How do we automate sort of our networking to support our applications, again, in these ephemeral environments where we have high levels of elasticity. And we're worried less about host networking and more about kind of modern service networking. Big focus for us there is console. And then at the very top is really thinking about how do we deploy and manage application lifecycle, deploy our applications, scale them up and down, push new versions, change configurations, and do this in a way that's sort of very developer focused and friendly. And there our focus is Nomad and Waypoint. So it's a broad portfolio of tools, really looking at what's the full spectrum of challenge as we're developing and delivering these modern cloud applications. When we talk about kind of HashiCorp, the company, we very much have a focus, on sort of enabling our commercial customers to be successful using these tools at sort of any scale. And so this is, startups that are born in the cloud doing bleeding edge things like Roblox, It's more traditional organizations that are transforming out of private data center and figuring out how to migrate to cloud and adopt more modern application platforms. And so today we count a little over 1,000 enterprise customers, more than 200 of the global 2,000, and 7 of the Fortune 10 as our customers. So when we talk about security, this has been a big area of focus for us, right? And our view is that as we're going through this sort of transformation from sort of on-premise infrastructure to sort of this multi-cloud world, there's sort of a fundamental shift in how we think about security, right? Our historic approach was very much based on what I'll call sort of a castle and moat, or a perimeter-centric design, where we had the 4 walls of our data center. We tried to bring all of our traffic through a clearly defined perimeter. And that's where we used, things like firewalls and WAFs and SIMs. And we created this sort of distinction between sort of the public untrusted network and the private high trust network. Now, as we're going to this sort of multi-cloud environment, we might have multiple different cloud environments. They might be connected back to our on-premise. And I think one of the challenges that becomes really clear is we don't have a definitive perimeter anymore. There's not a single point of entry or exit. We can make one API call to our cloud provider and accidentally make, our S3 bucket or our blob store public, right? We make one API call, get a 200 OK back. Now that thing sits on the public internet. So this idea of the perimeter really moves from a physical concept that we had on-premise to very much a logical concept that exists in the cloud, right? And to make matters worse, right, as we're sort of in these cloud environments, everything's becoming much more dynamic, much more ephemeral. So instead of long-lived VMs that might live for months and years at a time, we now have lots of containerized and serverless workloads that might only live for minutes at a time. So trying to map those back to sort of an IP-based mechanism of control is very challenging. So in our worldview, we need to kind of move beyond the perimeter model and start to embrace sort of a zero trust model. And at the heart of zero trust is really acknowledging that, I might make a mistake in the way that my perimeter defense is configured. I might have a weakness in an IAM configuration or a firewall or a WAF, or there might be a 0-day vulnerability, or there might be an insider threat or a phishing attack, whatever might be the case. I have to assume that my adversary is on my network, right? As opposed to sort of outside the 4 walls. And so if I assume my adversary is on my network, that really changes my whole approach to security. All of a sudden, it's not enough to secure the 4 walls. I need to harden the inside as well, right? So our view is, as we make this shift to this kind of zero trust model, what do we need to kind of hang our hat on in terms of defining controls, right? We move away from saying this subnet is trusted and this subnet's untrusted to really a notion of identity, right? What I really care about is saying my web server is allowed to talk to my database. My database administrator is allowed to, talk to my database. I don't really care about what IP they're coming from, because there's too much of that being highly dynamic, right? It's scaling up and down. The IPs are changing. It's ephemeral. I'm going through VPN and NAT and load balancers. All of them are rewriting IP addresses. So I sort of don't care about the IP. I care about the identity of the application or the user that's connecting, right? So as we make this shift to identity-driven control, our view is that there's sort of 4 pillars to this problem, right? One pillar is, how do we establish human identity, right? This is the most well understood problem. We've been doing things like single sign-on for decades, right? Whether it was with Active Directory or LDAP on-prem, or now with more modern solutions like Ping and Okta and Azure AD. It's a well understood problem, right? You want a central database of your users. You have a single sign-on technology, whether that's SAML or OIDC or some other cryptographic way of asserting identity. The other 3, I think, are less well understood. And those are the big areas that HashiCorp focuses on, right? So this starts with asserting machine identity. How do we have a strong notion of what is this application? What workload is this? Is it a web server? Is it a database? And what is that thing allowed to do, right? That's really where Vault focuses. Then we have the sort of machine-to-machine access, right? A web server is accessing a database. How do we put the right controls in place to say, great, that's allowed, but the web server talking to the API service is not allowed, as an example. And so in that machine-to-machine workflow, that's really where Consul is focused. It acts as a service mesh, so it can enforce those types of access patterns and push those enforcements down to the network level, but it also integrates in legacy environments where we might be using a firewall or traditional network segmentation. And so we can use Consul as well to drive automation against our hardware-based firewalls to do that same type of enforcement. So our rule set lives at an identity level, but the enforcement might be managed in multiple different ways. And then lastly is boundary, which really looks at the human to machine piece, right? So my database administrator wants to get access. How do we do that in a way that's, identity driven and simple, right? So diving a little bit further into Vault, at the kind of crux of how it works is this notion of creating sort of a three-legged loop, right? It starts with a client. That might be a human, might be an application workload. But the first activity is always to authenticate that client, right? There's sort of a login, if you will. And so that login might be human-oriented, right? If it's a user, they might log in with Okta. They might log in with Active Directory credentials. That's a very human-oriented process. A machine is unlikely to do, a web-based sign-in with Okta. Instead, the machine might do something like use Amazon IAM, right? Or it might use a Kubernetes service account. So in this way, Vault integrates with all of these underlying platforms, whether they're cloud providers, whether they're application platforms like Cloud Foundry or Kubernetes, so that we can assert the identity of the application. We can say, great, we know this thing's a web server, this thing's an API, this thing is a database, et cetera, right? So we start that first leg by asserting strongly the authentication and the identity of the client. Then on the next leg is really determining, based on that authentication, what is this sort of service principal allowed to do? If you're a web server, great. You can get database credentials, you can get a TLS certificate, you can get an API token to talk to a blob store, et cetera. You're authenticated and authorized to talk to a handful of these systems. So Vault will give you access to those tokens. And then to the extent possible, what we want to do is avoid giving static credentials. So instead of giving the web server a static database username and password, or a long-lived certificate that lives for 10 years at a time, instead we want to move towards sort of a tokenized value or an ephemeral credential, right? So instead of giving you a database credential that's valid forever and ever, I'll give you a database credential that can be used for the next 7 days or 30 days, right? I'll give you a certificate that's signed for the next 48 hours. I'll give you a cloud key that's valid for 24 hours potentially. And so what this forces is the client is periodically coming back and talking to Vault to get a new certificate or a new password. But this allows Vault to aggressively rotate those credentials so that we don't have long-lived static credentials in our environment, right? We create sort of a moving target for an attacker. And so this is the core approach, is kind of creating this three-legged loop using identity as the basis of authentication and authorization. Now, when we talk about Vault, it operates at sort of tremendous scale. We do almost 16 million plus downloads a year of just the Vault open source. We do hundreds and thousands of downloads of the Kubernetes integrations. We have customers that still serve trillions of secrets every year with Vault, and 70% of the top US banks use Vault as well, right? So it's used and trusted at sort of enormous scale at this point. And so if we kind of talk about the concrete use cases, right, one of them we sort of already talked about is this idea of secret management, right? So whether that's username, password, certificates, API keys, encryption keys, how do I get those out of source code, get them out of configuration management, get them out of sort of plain text all over the place, right? Which just tends to be what we see, is it's hard-coded in the app, it's hard-coded in Jenkins, it's hard-coded in a config file, and it has a really broad visibility and a low management, right, ability. So it's about moving all those credentials that are sort of sprawled all over in a state into centrally managing them with Vault, right? So they're encrypted at rest, they're encrypted at transit, we have tight visibility, we can do things like central rotation of credentials, et cetera. That tends to be the first key use case for Vault, right? Is sort of bringing all this kind of keying material that's all over the place and centralizing it. From there, once Vault's holding on to things like encryption keys as an example, instead of exposing the encryption key back to the application, and then the applications have to implement things like cryptography, Vault can act as sort of like a crypto API. So instead of saying, give me the encryption key, and then the app having to deal with encryption and decryption, instead the key never has to leave Vault. The application can use a high-level set of APIs to say, encrypt this for me, decrypt this for me, sign this transaction, verify this, tokenize, detokenize, et cetera. And so in the data encryption and advanced data protection use cases, it's really treating Vault as this sort of middleware to the applications so that they can offload key management, offload cryptography, offload password authentication, et cetera. But now we can do it in a way that we have a high assurance that the keys are never getting leaked. They can be rotated on a regular basis. The cryptography is implemented correctly, and we have a full sort of audit trail of everything that's been done. So it starts to move from just using it as sort of background distribution and storage of this material to really playing an active part in the application architecture and design in terms of how do we manage data in transit and data at rest in a secure way. And there's a few guiding principles to how we think about Vault, right? One piece of this is, you've heard probably the phrase identity a few times now, is at the heart of it is this idea of identity brokering, right? Is that identity is this now fragmented concept, right? I might have an IAM identity on Amazon. I have a different IAM identity on Google. Those two don't mean anything to each other, right? I can't use my Amazon IAM credential in any other environment. My on-premise Active Directory service account isn't valid anywhere else. And so can I use Vault as the sort of broker, right? Like I can log in using my AD credential on-premise, but then I can request a cloud credential that allows that on-prem app to reach out to cloud, right? Or vice versa. I might have a cloud-based application that needs to reach on-prem or needs to reach into a different cloud environment. And so it gives us this ability to kind of broker identity across these different systems and do it in a consistent way. The other piece of this is very much thinking about Vault is there to support applications, right? So whether that's deployment platforms, whether it's embedded into the application data path, at the end of the day, we're sitting in sort of a machine-oriented workflow, right? And so of course, all of this has to be API driven. Our expectation is, the Vault gets integrated into CI/CD systems, it gets integrated into applications, it's integrated into sort of monitoring and remediation and security tooling, et cetera. And so all of this kind of requires sort of an API-driven approach. In fact, an API-first approach, right? So for many years, Vault actually only had an API. It didn't even have a rich UI or CLI. Of course, that's, it's changed in the last few years, but this has been always sort of a driving principle, is very heavy API orientation. The next piece of it is acknowledging that there's a huge ecosystem of things that you want to integrate with, right? So it tends that you're not just managing a few static secrets, you're managing a database password, right? You're managing an Amazon cloud credential, you're managing, your message queues credential, et cetera. So instead of just holding static values for all those things, how can we extend and integrate with that whole ecosystem to actually manage those credentials in a dynamic way? So instead of just holding onto a static MySQL credential, Vault can instead integrate with MySQL directly, speak its API, speak its protocol, and now can do dynamic credential management and generate those sort of dynamic ephemeral credentials. And so there's a huge integration surface area of Vault. I think there's over 70 plus official integrations today. And so that allows it to integrate with an entire range of things from, database systems, message queues, key management systems, cloud providers, application platforms, et cetera. Now, we just released a few weeks ago the latest version of Vault, Vault 1.7, and I think there were sort of three big focus areas with this release. The first one was really thinking, again, back to ecosystem and broader integration. How do we continue to expand the horizon of integrations and add new capabilities? So I'll talk about that in a bit. The second one, and this has always been kind of a focus, it's sort of a forever one for us, is how do we make the system more reliable, more scalable, easier to use, right? Ultimately, we understand this is mission critical tier 1 type software that, if Vault goes down, has large ramifications to the rest of your infrastructure. And so we take that very seriously, and we constantly invest in how do we push that envelope? How do we learn from what our customers are doing and make the system better and more resilient? And then the last one is increasingly focusing on these sort of advanced data protection use cases of great, not just the low-level secret management, but how can we provide higher level, richer facilities to the developers who are trying to protect data at rest, data in transit. So when we talk about the ecosystem integration, we continue to integrate with more and more systems, right? With this release, we added 4 major new ecosystem integrations. One was Snowflake secret engine. So now you can get dynamic credentials if you're using Snowflake as a data warehouse. We added a Terraform secret engine. So if you're using Terraform Cloud or Terraform Enterprise, you can also manage dynamic credentials. We integrate with Active Directory. So if you need to dynamically create service accounts for your on-premise applications, that's supported. And then we added a CSI driver for Kubernetes. And so this allows secrets to be sort of materialized as a mounted disk. So to the application that looks like credentials are on disk, but they're really being sourced from Vault and then being managed behind the scenes through the CSI driver. So this just makes the integration with a Kubernetes environment even easier. The next big focus area was really thinking about reliability and ease of use. And there's been 4 major improvements here, right? One is integrated storage autopilot. So in the last few versions of Vault, we've been promoting this sort of internal storage management, as opposed to historically with Vault, you've had to have an external either database or console or something as the backing store. Now Vault more directly manages its storage. So we're bringing some of our autopilot capability from our other products like Console and Nomad in that simplifies the management of that as well. In addition, we've added agent-side caching. So for environments like Kubernetes, where you might have very ephemeral workloads that are coming and going, this allows us to sort of scale up the system and minimize the load that we're putting on the central Vault clusters. If you have a ton of containers coming up and down regularly that share the same few credentials, it allows that to be a lot more efficient. Automatic barrier key rotation. This is sort of an exciting and unsung piece, right? To me, it sort of speaks to the level of attention, which is the underlying encryption keys that are used to protect Vault's data at rest. Historically, there was a manual command you had to execute to rotate those things. And it's one of these things that unless you're doing the estimation of how often am I doing operations, how frequent are my writes, how close am I getting to key reuse, it's sort of a difficult thing to estimate, right? And so in practice, a lot of people wouldn't rotate those underlying keys on a regular basis. Now Vault takes that on for you. It aggregates the number of write requests taking place. It can automatically detect when you're getting close to a threshold that you might be risking key reuse, and it'll automatically rotate the underlying keys for you, right? So this becomes one of those things that just reduces the cognitive burden, but also increases the security of the system and does it in a way that's invisible to the user. And then the last piece is making the Vault Enterprise trial much easier. If you're using that to do integration testing, or you've baked it into an environment where you need to download it, run it in a CI, et cetera, test against it, there's now an automatic 6-hour license that's baked in that allows you to more easily do those kind of testing and integration environments. And then the last one is the focus on advanced data protection with 1.7, right? And there's 2 big areas here. One is tokenization. And so this is really looking at the cases where you might say, great, I could give a credit card key and say encrypt, but then the thing that comes back doesn't look like a credit card key. It looks like a random bit of ciphertext. Versus with tokenization, you say, great, I'm going to give you a 16-digit number. I need a 16-digit number back. This token represents the underlying credit card, but is not reversible to it. It's not an encryption. It's a true token. That token can be sort of traded in, and then a look-aside can take place to get to the real value, which is encrypted at rest. And so this allows you to more easily protect data inside existing systems where you have fixed schemas, fixed APIs, fixed sort of validation logic that you need to preserve, right? So that's been a big ask. And now there's a production-ready version of that as well. And then key management as well. We now have GA'd the integration with Azure Key Vault. AWS KMS is now in beta. And this really looks at how can I use Vault as my root of trust and then sort of bring my own key into these, Azure Key Vault, AWS Key Vault, et cetera, and manage the sort of rotation and the core storage of those keys centrally from Vault, right? So really excited about what this enables in terms of more effectively being able to do central key management, even in a large distributed cloud environment. So that's great. We spent a lot of time talking about, what is Vault, right? What are some of the new capabilities in the 1.7 release from, 2 weeks ago? But what we continue to hear from customers is, yes, we know that adopting zero trust security, we know adopting things like Vault is foundational, but we don't have the operational skill set to have to run this thing at scale, or it takes us too long to actually get this deployed and stood up in a production-worthy way, right? And so this is frequent feedback we've gotten. And I think ultimately our answer to this is the HashiCorp Cloud Platform, right? So the HCP, short for HashiCorp Cloud Platform, is really our chassis for delivering managed service versions of all of our products. So it will span all of the common cloud providers, and it will provide all of the HashiCorp tools as a managed service on top of it. And so, in our view, this doesn't change what we've been doing, right? We've always had the option of customer managed. This is sort of the existing way most of our customers consume and download our software today. You can continue to do that. We will continue to invest in that and make sure our self-managed customers are successful. But in the future, we will add a new option through HCP where those same services can be consumed as a HashiCorp managed service as well, running in a cloud environment. So it's sort of expanding the menu of options so customers can choose what makes most sense for them. When we talk about kind of the vision of HCP, it ultimately comes down to kind of three key goals, right? One is that the deployment and stand-up should be push button. It should be that easy, basically, to get up and running. Two is that this is fully managed, right? The full life cycle, not just of stand-up, but backup and restore, disaster recovery, upgrades, monitoring, etc. The whole thing should be provided as a managed service, right? And then the last piece is that it should be the same fundamental workflow, even if you're multi-cloud. So even if you're spanning multiple cloud regions, but same provider, or you're spanning multiple regions and multiple providers, all of it should be the same consistent workflow, right? So for our customers that operate in a multi-cloud way, they don't have to have a fragmented experience in terms of like, how are they managing that infrastructure? And so great, the push button deployment should look as easy as filling out some names, some detail, like what region you want to be, what tier you want to go, and then push go, right? Again, when we talk about fully managed, you can see here, you can see the version, you can see the health status, you can do some high level operations, but all of the sort of underpinning, sort of making sure this thing is running and scaled and available is sort of the HashiCorp problem. And then here, the kind of core sort of a piece to enable this workflow around multi-cloud is what we call an HVN, or a HashiCorp virtual network. You can think about an HVN as sort of a one-to-one mapping of sort of a VPC or a VNet in the cloud, but the goal is that we abstract at one level higher. So within HCP, you only think about these virtual networks, you deploy your application into an HVN. So you might say, I want a Vault cluster in this particular HVN. And then we're able to mask some of the differences underneath in terms of the various cloud providers. So providing that more consistent experience on top of the HVN. So earlier this year, about 2 months ago, we launched the first service into general availability on HCP, and that was the HCP console service on AWS. And so this is really looking at, great, how do we bring service networking, right, and provide it as a service across any cloud, through console. And so at the heart of what console really does is provide that consistent directory, that service registry of what everything is, where is it all running, and then enable that to be flowed down either into sort of software-based proxies like Envoy, Nginx, HA proxy, and act as a control plane to a service mesh, or it can integrate into a traditional network where we're updating, an F5 device, a checkpoint, a Palo Alto, a Cisco device, and doing sort of network infrastructure automation against hardware. So that really the end goal is the same, is we want to support our application developers, let them focus on deploying their apps, scaling up and down, pushing new versions, and have the network automatically update to support them, rather than file a ticket and wait for the network to sort of update days, weeks later. Now, today, I want to focus on sort of the new piece that we're talking about. We sort of started this webinar by announcing the GA of Vault, so you kind of know where this is going. And so our focus over the last sort of 6 months has really been getting this service to a production ready state, right? We had first announced HashiCorp Vault back in 2015, but it was really only in October 2020 that we announced HCP Vault will become a service, right? And we started work several months before that. November of last year is when we went into private beta. January of this year, we've opened it up to public beta, where we had over 1,000 customers enter the public beta process with us. And now we're excited to take this generally available this week. And so what's some of the feedback we've been getting? It's been super exciting to see this feedback come back in, right? It's sort of exactly what you'd hope for, that it's easy to, create clusters and operate, that it's intuitive, that it's easy to integrate back into the systems they're using, that it saves people time on the stand-up and operationalization, that they wish we had done this, earlier. And so this is great, exactly the type of feedback we would have hoped for. Right. Some of our biggest customers are already leaning in and starting to explore this as well. Lufthansa, for those who are unfamiliar, is a major global airline. And I think what they've shared is basically the simplicity of this thing and the fact that they can get a much higher level of reliability and get the expertise of HashiCorp managing this for them, as opposed to having to build that expertise themselves, is what's critical. We're also very excited to work with our partners on this, right? As I said, there's an extensive ecosystem we work with. And so working alongside folks like MongoDB to certify the integration between HCP Vault and their Mongo Atlas service is critical for us, right? We want to make sure as customers are using this, that they have a seamless experience with the rest of the ecosystem. And so it's great to see the support of them as well. And so, without further ado, HCP Vault is generally available today. Anyone can sign up. You can just go to hashi.co/cloud platform to sign into your HCP account, and you should see the service ready to go. Now, as part of that, we're launching with a few SKUs and several different regions, right? So we'll have two pay-as-you-go hourly SKUs, one that's really focused on the development use case. So as you're bringing up environments for dev environments or CI/CD, staging, testing, etc., this gives you a really low-cost way to spin up a managed cluster, use the same API, use the same managed service, but it's not designed to be a production service. So it's a single node. It doesn't have the same SLA. It doesn't have backups on a regular basis. It's very much designed for development environments and low cost. Then we have our standard SKU, which is really designed for sort of at scale production environments. It's fully managed. It's highly available, has backups and monitoring and a much higher SLA associated with it. And then for customers that plan to operate this stuff, not necessarily in sort of a stop and go hourly basis, there's an annual contract option, which gives you sort of different levels of discounting and different multi-year sort of pricing commitment options. Right. Today we're just launching with AWS and 5 regions, so you can kind of see at the bottom here, and that includes sort of US West 2, US East 1, US West 1, US West 2, and EU Central 1. And over time we'll be expanding that list to add more regions and add more capabilities. Now, a quick peek into where is this going. Obviously, this is just the launch. We're sort of not done here, and there's sort of much more to come. In the very near term, we want to look at adding additional tiers. So we realize right off the bat, those 2 tiers might not be sufficient for everybody. So we will look at adding an additional tier above the standard SKU, which brings in some of the advanced data protection capabilities around encryption and full disk encrypt and tokenization and things like that. We'll also look at a lower production tier as well to sort of fill that gap between the development SKU and the standard SKU. So maybe you're not quite at an at-scale environment, but you still want to start off with a managed Vault instance. We will work on filling that gap in the near future. And then there's sort of a broad set of capabilities we've been asked for through the beta process. This is everything from transit gateway for customers using that Amazon pattern, multi-region support. So within Amazon, if you want a cluster that exists in multiple regions and is replicated, that'll become available. And then we will work on multi-cloud support in terms of adding additional clouds and regions as well, right? And then within all of that, additional feature work, additional workflow refinement to make it a smoother, better process, right? So this is just us getting started. There's a lot more to come here. So with that, I will hand it over to Justin, who's going to actually run us through a live demo of the product.
Sorry, I'm just got to share something here.
Great, thanks Armon. So my name is Justin and I'll be running through the demos today. I wanted to do a bit of a technical deep dive on how to get started with HCP Vault. My high-level intention here is to gradually build up our understanding of what's happening under the hood and get you pointed in the right direction if you want to learn more. Alright, so let's dive in. The first thing I wanted to show you was the learn.hashicorp.com website. If you haven't seen it before, it's sort of a goldmine of great hands-on tutorials for learning the ins and outs of Vault. Say for example that you wanted to use Vault to store static secrets, things like usernames and passwords. Well, there's a step-by-step guide on that. What about if you wanted to generate short-lived AWS dynamic credentials? Say for example you have a backup job that runs periodically and you just need a short-lived credential for that. Well, you can see we have a guide for that as well. We'll actually look at a demo of this in just a couple minutes. Or maybe you have a AWS RDS database instance and you want to rotate the credentials. Well, we have a guide for that too. What about more advanced use cases like injecting credentials into a Lambda workflow? We got you covered there. Or what about injecting secrets into a Kubernetes workflow via a sidecar container? You sort of get the idea. That's why I wanted to show you this site, because it can be a great companion as you're learning about HCP Vault. All right, so let's jump over to the HashiCorp Cloud Platform portal, or just HCP portal for short. You can sign in or create an account. I'm just going to sign in. This is what you get when you first log in. Over here on the left, you have options to access the dashboard, create virtual networks. We'll talk about those in a minute. Then you have access to create managed instances of Console, Vault, or Terraform. Then down here, you have some account and billing stuff. On the main page here, you can also create Console and Vault instances via these shortcuts, along with a summary of your account. And then here, there's some of those links to the Learn guides I was just chatting about. And then there's a way to contact support if you need help. All right, since we're here to talk about Vault, though, let's have a look. I've already created 2 Vault clusters here, a single node developer instance and a multi-node highly available production cluster. Before we play around with those, let's look at what the Create Cluster page looks like. So up here, you can enter the cluster name. You can select the AWS region where you want the cluster. Then down here, you can select the type of cluster you want. Say I wanted a non-production developer instance, or we have a 3-node highly available cluster over here. All you need to do is just select the option that you want. Say I select the standard production cluster over here. You actually get a breakdown of 3 different options, small, medium, and large. The main difference here is the hardware that we run your Vault cluster on. Then down here, we have an option to give this instance a public IP address. We don't recommend doing this for production, but it can be really useful when you're first learning about Vault or just want to prototype something. I'm not going to click create, but if I did, it would kick off a process to build this cluster. All right, since I already spun up a couple different clusters, let's have a look. You can see our cluster name here. Then we have a snapshots tab where you can back up and restore from snapshots. This cluster tab gives you metadata about the cluster, like the instance size and when it was created and that type of stuff. Then up here, you have options for how to connect to the cluster, say for example through the API or CLI. Then over here, you can edit the configuration or delete the instance. We provide some metrics about the applications that are hitting the Vault cluster, and then we have some metadata here about the cluster and how to connect to it. For example, via the private or public addresses. On this cluster, I chose to expose a public address just for testing. Actually, I put together a few diagrams that might help explain how things are wired up, so let's jump over there just for a minute. HCP has something called HVN, or HashiCorp Virtual Network. You can think of this sort of as a secure holding area where your Vault instance is totally isolated from anyone else. Then as you provision new instances, they can appear within this network. For example, a single node developer instance or a multi-node standard cluster. We then give you the option of how you want to connect to this. So when you created this cluster, if you said, hey, I want public access, we'll create a public IP address and then route traffic from that IP address into this private network. So then you can access the cluster via the web interface, API, or CLI. So this is public access, and I'll chat about peering in just a minute. So if you wanted to access this cluster, we could generate a token where you could access the logs to say debug how something's working, or you can also seal the Vault to make it inaccessible. All right, so let's jump over to our first demo. I'm going to copy the public address here and then open that URL in a new browser tab. Great, it works. So that's sort of uneventful though, it just works. You do see that we're asked for a login token, so where do I get that? Well, let's jump back over to the HCP cluster page. Then I'm going to generate a token here. Just takes a second. Then we'll copy this token, close this out. Then we'll jump back over to the Vault page and paste that token in here. And we're in. So we have a standard Vault instance here with the default secrets engines enabled. All the normal tabs you'd expect. But you can also access it via the command line. So let's jump over there and see what that looks like. Behind the scenes, I've already downloaded the Vault client onto my laptop. We're just going to use that to remotely connect into this managed instance of Vault. So the first thing I'm going to do is set that Vault address string. This tells the Vault client, hey, I want to connect to this Vault server. Next, since this is running Vault Enterprise, we need to specify the namespace. Then I'm going to set the access token we requested earlier. Great, so we're all set up. Now let's try and list the secret engines and see if it works. Great, we get back a list of what's running on the server. So if you remember from earlier when I was showing you those Learn tutorials, we have sort of a hello world example for Vault. First, I'm going to enable a key value secret engine. Next, I'm going to put a static secret into Vault, storing a username and password. Great, that worked. Now let's try and get it. Perfect, that worked. With that out of the way, let's look at a more complex example. I want to remove the public address by editing the configuration. All you need to do is toggle this to remove public access. Then we'll update the configuration. This takes just a second. Great. Now we don't have a public address, but how do we actually connect to this? To help explain how this is going to work, I have a couple more diagrams that I just wanted to walk through. So we start just like we did before with our instances located in the HCP virtual network. But say you wanted to securely access these managed instances of Vault from your AWS VPC. In your AWS environment, you likely have EC2 instances, you probably have Kubernetes, you probably have database instances, and you're probably using subnetting and all the recommended stuff. The way we establish this secure connection between these two networks is via VPC peering. What's so great about this is that you get a fully managed instance of Vault directly connected to your private AWS environment. So let's jump back to the HCP console and actually set this up and test it out via a couple demos. So to manage these peering connections, let's go over to the HashiCorp virtual network page. In here, you can see I've already created a virtual network using AWS. It's sitting in US West 2, and you can see we're using a non-routable 172 address space. So let's go in here and set up peering. This page shows pretty much the same information, but it also shows what Vault clusters we have sitting in this virtual network that we can peer with the AWS. So let's go over to the peering tab, then we'll select create a peering connection. This will just take a couple minutes, but I wanted to walk through it step by step and sort of methodically walk you through the process, because chances are when you first set up your environment, you're going to have to do this too. So to establish this, we need 3 pieces of information from the AWS environment you want to peer with. You need the AWS account ID, the VPC ID, and the address range of the VPC. So let's go grab all this information. I have a tab open here with an AWS console, and I'll show you step by step how to find these values. So we're over in the AWS console, and this is the VPC I want to peer with. The first thing we need to do is find our AWS account ID. You can find it up here under account settings. I'm just going to copy this number. Then we'll jump back over to the HCP portal and paste it in. Next, we need the VPC ID. This is easy enough. We just go back. We're going to copy this value, and then we'll go back and paste it in. You can see here we need to select the region, but this is already defaulted, so we're good. Then we need to get the address range of the VPC. You can find that here. We're going to copy this, then we'll go back and paste it. One really important thing here is that the 2 address spaces can't overlap, because you won't be able to route traffic correctly if that's the case. All right, so let's create the connection. So what's happening behind the scenes here is that HashiCorp is reaching out to AWS and asking to peer with this VPC so that we can provide a secure private connection to Vault. In a second here, we should see this flip over to pending acceptance. Great, so now what we need to do is jump over to the AWS console and accept this peering request. Over on the left-hand menu here, if we scroll down to peering connections, we should see the request in here. Great, so we just right-click on this and click accept. We make sure it looks good. I'm going to confirm it. Okay, we're almost done. So let's go back to the HCP portal and see what happened. Should just take a moment here and we'll see the request was accepted. Then once it's accepted, it should flip over to active. Great, so we've successfully created a private connection and it's active. Let's click in here and check it out. The final step here is that we need to update the AWS security groups and route table so that we can actually route traffic between these 2 virtual networks. In this section, you can see step-by-step instructions for updating your AWS VPC. You can think of these as command templates. We just need to provide a couple values. I'm going to use the Vault template here. So we need these 2 commands. One is for modifying the security groups to allow access. The second one here is to modify the routing table so that when the AWS VPC sees traffic for the HashiCorp virtual network, it knows that it needs to send it over the VPC peered connection. All right, so let's grab the values we need here. This is the final step. I promise it's going to go pretty quick. So let's jump back to the AWS console under the VPC area. Let's go click on security groups. You can see I have a few different ones, and you probably do too. This is sort of where it's environment dependent, and you need to figure out what AWS resources need access to the Vault environment. In my case, I'm just going to select the default one. I'm going to copy this and then jump back over to the HCP portal and paste it. The second thing we need to do is figure out the routing table that we want to update. So let's go over to the AWS console, to the route tables page. Again, like I do, you probably have a bunch of values here and need to figure out which one. But I'm just going to select the main route table. I'm going to copy this, and then we'll go paste it back over here. All right, I think we got everything figured out now. We have our commands. All we need to do is run these commands over on AWS to get everything configured. The nice thing about this is chances are you're not going to be doing this every day. It's sort of a one-time initial thing you're going to do when you first set up your environment. And I wanted to provide sort of step-by-step instructions here. So let's copy the first command here. And then I actually have a AWS command prompt open. I don't know if you've seen this before, but AWS added this cool command prompt option. All you need to do is click the command prompt icon and it opens a command shell right in your AWS environment. So I'm going to paste the first command to modify our security group. I'm going to run that. Great, so we just modified the AWS security groups so now they can talk to Vault. Now we need to make sure traffic is routed over to that VPC connection. So let's copy this command. Then we'll go back to the AWS console. I'm going to run that. Great, so we should have everything working right now. I think we've set up all our security groups and the routing table to just work. The only thing left to do is actually test this out. Let's go back to the menu here, click into the Vault clusters again, and then click on the standard cluster where we remove the public address. So what I wanted to do for the final two demos here is actually SSH into an instance sitting in my AWS environment and then securely connect to Vault over that peered connection. This will likely mimic what you're going to do in a production environment. So I'm going to copy the private address string here. We don't need to, but I'm going to generate another token just because I don't remember what the other one was. I'm going to copy this down and we'll close this. Then I'm going to jump over to the command line where we can actually walk through a few demos. All right, so I have a terminal open here where I've SSH'd into an EC2 instance sitting within my AWS VPC. I'm going to set the Vault address to that non-public instance that's only accessible via our peered environment. Again, I'm going to set the namespace since this is Vault Enterprise, and then I'm going to paste in that new token that we just generated so that Vault knows how to connect to this instance. Let's run Vault secrets list again and see if it works. I know this is very simple, but it proves that we're talking over the secure connection within our AWS environment. In that earlier demo where we were talking over the public address, we set up that example key value secrets engine and set an app username and passwords where dragons love salsa. So let's try and fetch that secret. All right, so let's move on to the final demo. So since we're in AWS, say you wanted short-lived, tightly scoped access credentials, maybe for integration testing or some type of automated scripts. We can use the AWS secrets engine to do just that, so let's enable it. Next, I'm going to set up the configuration by passing in our AWS access credentials and region. Then we'll set up a simple AWS role that says, hey, for credentials generated with this, I want it to have this policy attached. In this case, it's EC2 access. Sort of the high-level concept here is that you can use Vault like a remote control for AWS IAM credentials. Everything should be configured now, so let's generate some credentials. So what you're seeing here are AWS credentials that are generated by Vault that have that policy attached, as well as a time to live, so they're active for about an hour. This is pretty cool. But I don't necessarily want anyone accessing my environment, so let's revoke these tokens. Before we end, I just sort of wanted to circle back to where we started with that learn.hashicorp.com website, as there's tons of tutorials on there that have all the use cases defined really well, and it gives you step-by-step instructions. So Armon, I think we're going to open things up to QA, so I'll stop sharing now.
Perfect. Thanks so much, Justin. We did have a lot of questions come in, so I'll kind of kick things off. The first question that I wanted to pose to the group was, we had a user asking if we could share thoughts on using Vault for crypto ops as middleware, as we mentioned earlier in the presentation, and kind of what the performance considerations are around that.
Yeah, I think this is a really great question. I'm glad somebody asked it. So I think it goes back to sort of, I think our design principle is very much that Vault is designed for API-driven machine interaction. And so, I think the core of how we've designed it is both a scale up and scale out architecture. So as we throw sort of more CPU cores at Vault, each individual instance of Vault is able to kind of consume that, and we can get more concurrent throughput out of each instance. We also have a technology we call performance standbys. So if we take sort of a 3-node cluster, for example, in the standard configuration, only the active node is processing requests. In a performance standby configuration, the other 2 nodes would be able to add to that sort of cryptographic or read-only throughput as well. And then we could add even more nodes, right? So we could go from 3 to 10 nodes if we needed to keep adding more throughput. So in practice, we have customers that have clusters doing over 100,000 QPS per second. They have sub-millisecond requirements. One of my favorite use cases is we have a stock exchange that every trade is authenticated by touching Vault. And so it's very much designed to operate in that like mission critical path, very high throughput, very low latency. And so it's a bunch of these different pieces built in from, scale up, scale out, standbys, et cetera, that allows to kind of scale up the cryptographic throughput of the system. But yeah, great question.
Awesome, thanks. So next question that came through is if we could explain plans to expand HCP managed Vault clusters to other cloud providers.
Sure, I'm happy to take that one. I don't think at the moment we have a committed plan, so we don't have a committed timeline. I will say what's very top of mind for us is, from here, next step is the multi-region support within AWS. So there's a bit of missing depth and functionality there. And we already mentioned some of it, things like transit gateway, things like multi-region support, additional regions that we want to light up. And then hot on the heels of that is really then focused on Azure and GCP as the next expansion targets. So it's very much top of mind. We're going through the scoping exercise now. As I said, sort of, we have this kind of almost 2-layer challenge, which we have the HashiCorp platform, and then the services on top, at this point, Console and Vault. So for us, the first step is expanding HVN support and the underlying network primitive that the HashiCorp cloud platform supports to these other environments. And then from there, the Console and Vault services will be updated to make use of them as well. So very much top of mind, something we're working on. Hopefully we'll have committed timelines to share later this year.
Awesome, thank you. So next question that came through is the billing a simple per hour rate, meaning there are no limitations like the number of entities?
Sure, so I'm happy to take this one. So the billing for HCP Vault is really the idea around there's a base license cost per cluster, and then there is also a cost for each client that sits on top of it. So you can scale those kind of unlimited scaling in terms of the number of clients or like users and applications that you want a cluster to support. So there are no limitations in that, and you can also scale up as many clusters as you like.
I'm not sure if we lost Aubrey.
No, I'm here. Perfect. Well, I think we were able to answer most other questions within the Q&A chat. So I think we're good to close out. So thank you so much, Armon and Justin.
Thank you so much.
Hey,
thanks everyone for making the time to join today.